For example, 4, determine the points of inflection and open intervals on which the graph of f of x equaling rational function is concave upward or downward. So same thing that we did in the previous exercise, but there's going to be an added complication as you're about to see. Okay, so how do I start this? Again, what I need is the second derivative. Second derivative is how I'm going to test for concavity, and where that second derivative is equal to 0 or undefined, that's where we could have some possible points of inflection. So before I even start that, what I do want to call your attention to is the fact that down here, x squared minus 4, that can equal 0. This time, x squared minus 4 equals 0, so x is equal to plus or minus 2. Actually, it can't be equal to plus or minus 2. And if I plug either of those 2 points in the top, you don't get 0. So you get some number over 0. These things are going to be vertical asymptotes. Right? Okay, so keep that in mind. So if we find some supercritical numbers that are plus or minus 2, we know that they're actually not. They are vertical asymptotes. Same thing would be true for relative mins and maxes, right? Okay, so let's find our derivatives, starting with the first one. So we'll have to use the quotient rule once again. So the derivative of the top is a 2x times the bottom, x squared minus 4, plus, no, it's minus. The derivative of the, no, it's the top. Yeah, there we go. X squared plus 1 times the derivative of the bottom, 2x. And then all of this divided by x squared minus 4 squared. Right, and then I definitely want to clean this up before continuing, just because it's going to make my life a lot easier whenever I go to find the second derivative. Yeah, okay, so let's do some distributive property like it's algebra 1. We got a 2x cubed minus 8x, and then distribute not just the negative sign, but the 2x as well, so it's like I'm distributing a negative 2x through that, so a negative 2x to the third power, and then minus 2x. Yeah, that looks right, over x squared minus 4 quantity squared. Hey, this is really convenient. Let's get out my cancellation crayon and cancel these things out. Okay, I know it's been a minute since I've taken out my cancellation crayon, hasn't it? All right, so we have a total of negative 10x over x squared minus 4 quantity squared. And hey, notice that x could be 0 up here. If x was 0, then the first derivative is equal to 0. That would be a critical number, and that's a possible point where you'd have a relative min or a max. Right, all right, let's just keep going, though, because we want supercriticals. We want concavity here, so we need to find our second derivative. Have to use the quotient rule again. So the derivative of the top, negative 10 times the bottom, x squared minus 4 quantity squared, minus the top, so minus a negative makes a plus, 10x, times the derivative of the bottom. Let's leapfrog the 2 down, x squared minus 4 to the first power, times the derivative of the interior, 2x. Close and close. Closed them enough, I think. I could close it a couple extra times if you want. That's just silly. All right, over x squared minus 4 squared squared, so to the 4th. All right, and then let's fix it. Let's make it look pretty. So let's do some cancellation yet again. Notice that everything has a factor of x squared minus 4 in it, so we're going to cancel one here, and cancel one down there. All right, when we cancel it, right, we're just dividing it out. You could factor it, but who's got time for that? Nobody. Let's do some more distributive property. Distribute that negative 10 through the parentheses. All right, I have a super important phone call, so I'm going to have to stop the video right here.